Good day, everyone. I am Faith Hazelhope F. Opanes. So today, the group 2 will discuss the topic about servicing the domestic refrigerator. So at the end of the lesson, the students will be able to know how to use the ammeter, how to find the CSR, or also called as the common start and run of our reciprocating compressor, the common troubles and remedy for an effective motor compressor, and also the students will be able to know in checking current or push-on type relay, overload protector, the thermostat, the cabinet, the bulb and switch, and in charging refrigerant in domestic refrigerator. So how to use the ohmmeter? But before that, what is an ohmmeter? So an ohmmeter is an electronic device mainly used for calculating electrical resistance of a circuit. And the unit of resistance is called ohm. So the working principle of ohmmeter is it comprises of a needle and two test leads or two test probes. The needle deflection can be controlled with the battery current. Initially, the two test leads of the meter can be shorted together to calculate the resistance of an electrical circuit. Once the two leads of the meter are shorted, then the meter can be changed for appropriate action in a fixed range. The needle comes back to the highest point on the meter scale and the current in the meter will be the highest. So here's a diagram of an ohmmeter circuit. So once the testing of the circuit is done, then the test leads of the meter must be detached. Okay, so once the two test leads of the meter are connected to the circuit, then the battery gets discharged. When the test leads get shorted, then the rheostat will be adjusted. The meter needle can be reached to the lowest position, that is 0, and then there will be 0 resistance among the two test leads. So to better understand the working principle of an ohmmeter, here's how to use the ohmmeter. So first, disconnect completely and or turn off all power to the circuit you are testing. So you must have a completely dead wire or circuit in order to ensure accuracy in measurement, as well as your own safety. Okay? So your ohmmeter will supply the voltage and current for your circuit, so no other power is necessary. Then after that, connect testing wires to the ohmmeter. Then the black wire goes to the ground outlet, then the red wire to the volt or ohms outlet.
So set the dial to the ohms setting with a multimeter. So see highlighted red square in image. On an individual ohmmeter, you may have to set a range for the readings. In ohms, kilo ohms or mega ohms, mig ohms. Use the range you located in the service manual to set the dial. Then connect the ohmmeter wires to the plug wires, metal to metal. It doesn't matter which wire goes to which end. The test will work either way. Check the ohmmeter reading and see if it falls in the range listed in your service manual. Plug wires have a set resistance. Place the wires in the connectors that normally link the switch to the house wires. Know that a reading of OL means over limit. That means the resistance is off the charts and you have a break in the circuit. If you got an OL reading for the plug wires, you'd know there was a broken wire that needs replacing. In this case, we got an OL reading because the light switch is in the off position. Consider that a low reading anywhere from 0 to 0.5 indicates very little to no resistance. This means there's a continuity of current in the circuit. This is the reading you should get when the light switch is in the on position. Remember, overlimit or OL means there's too much resistance and a break in the wire somewhere. A near zero reading indicates no resistance and smooth flowing current. In circuits like plug wires, where a set range of resistance is necessary for them to work properly, any reading other than the proper range indicates bad wires that need to be replaced.
Okay, next topic is how to find the CSR of a reciprocating compressor. But before we go beyond in that, we will know first what is the reciprocating compressor of the refrigerator. So what is? So a reciprocating compressor, also known as a Scotch yoke compressor, is designed to give years of reliable service. The main component of a refrigerator is the compressor. What is the main component of the refrigerator? It is the compressor. High quality is very important. Why? Because if the compressor is in a high quality, there is an instances that your refrigerator will last longer. So this type of compressor consists of a reciprocating piston, operating and stationary cylinder. So in a reciprocating compressor, there is a reciprocating piston also that is operating in a stationary cylinder. So there are four functions of the reciprocating compressors. One is it is actuated through a sliding yoke by a crank on the upper end of a vertical shaft. Second, the shaft is made of hardened steel and runs in cast iron bearings. Third, the upper bearing is self-aligning, which helps eliminate wear. And lastly, a rotary oil pump is at the bottom of the shaft, which keeps the compressor lubricated and operating smooth through years of the use. So these four functions is actually found in the reciprocating compressors. So reciprocating compressor is a compressor that employs back and forth piston motion to compress the vaporized refrigerant. So what is the function? It employs back and forth piston. Another name for this reciprocating compressor is the piston compressor. This compressor comprises a motor, crankshaft, and some pistons. What is motor? The motor rotates the crankshaft, which then pushes the pistons. So the motor will rotate the crankshaft, in which it pushes the pistons. So in every crankshaft rotates, there is an active actions, which are the suction, compression, and discharge. And all these actions are in a sequence. As a result, gas displacement is continuous and causes vibration. So in every crankshaft rotation, there is a sequence actions, which are the suction, next is the compression, and lastly is the discharge. As a result, there is a gas displacement which causes vibration. So there are two types of reciprocating compressors. One is the single acting reciprocating compressors are those compressors where the refrigerant acts on one side. One is the double acting shock compressors. Enjoy refrigerant action on two sides of the piston. So what is the types of single acting compressors? There are four types. One is open type compressor. Two is serviceable semi-hermetic compressors. Third is bolted serviceable semi-hermetic compressors. And lastly, welded hermetic compressors. So these reciprocating compressors comes in low, medium, and high operating temperature. You find reciprocating compressors in household refrigerators and freezers. In commercial refrigeration and air conditioning systems are semi-hermetic and welded hermetic compressors. So, what is CSR? As we all know that our topic is how to find the CSR, but we don't know what is CSR. So, CSR is the acronym of Common, Start, and Run. Common is just a point between start and run. and therefore the common to start and run to start readings will add up to the run to start reading. Many will tout this as a diagnostic reading you should check. So the colors of the individual wires are usually follows. So black for common, yellow for start, and red for run. Some refrigerators use a pin-type plug-in receptacle for compressor connections. Identify the pins by the following letters: C for common, S for start, and R for run. Always remember that CSR has the following color of these individual wires. C is for black, S for yellow, and R for red. So, how to find the CSR of the compressors? So, when testing of compressors, to find out the CSR of the compressor, use multimeter and also can find out the CSR of the compressor by test lamp. So first we should do is we use the multimeter to find the CSR of the compressor by the test lamp. Next, first switch off the system and remove the compressor terminal or cover. So we should first switch off the operating system and we remove the cover of the compressor. Next, insert the probe of a multimeter in a common point and second probe in ohms and set the multimeter in the buzzer direction. So there are two probes. So first, we should insert the first probe of a multimeter in a common point and the second probe in ohms, and we set the multimeter into the buzzer direction. Next, alternatively touch the probe of a multimeter in the two terminals out of the three terminals of compressor and record the reading. So we should alternate the probe to touch it in a multimeter in two terminals out of the three, and after you touch the probe, you should record the reading. By this reading, one can easily find out the CSR of the compressor. So every terminals you should record the readings. So this time we can easily find out the CSR of the compressor. So the highest reading will be the start winding. So there are three terminals of compressor. So when you are done putting the readings, or when you are done recording the readings of the three terminals, you should identify which is in the highest reading. So the highest reading will be the start, and the medium reading or the second to the highest will be the run winding, and the lowest reading will be the common winding. So as you can see in the illustration below, that this is somewhat a common example of the CSR. So we should note that fault finding in compressors, when we can say that there is a fault finding in compressor, there is an unexpected sounds from compressors like knocking, grinding, and many others. So that's all. It's talk about how to find CSR of the compressor. Hope that you learned something.
Good day everyone, my name is Hannah Jimby Pasinaba of BTLED IA 32. Moving to the next topic, we will be tackling about the common troubles and remedies for a defective motor compressor. The first trouble would be 1. Overheating. Overheating is probably the most common cause of compressor failure. If your compressor is running too hot, you can risk a breakdown or expensive repairs. And there are three main reasons why your compressors might be overheating. The first would be the high condensing temperature. This is normally caused by low evaporating pressures, which leads to a higher compressor discharge temperature. Possible causes include dirty condenser, high temperature condenser, fan motor malfunction, insufficient airflow to condenser, overcharged refrigerant, and wrong refrigerant. The second would be the low evaporator pressure or temperature. If your evaporator pressure is low, your compressor will need to work extra hard to compress the refrigerant, raising its discharge temperatures. The reasons would be dirty or iced over evaporator coil, dirty air filter, insufficient airflow, evaporator fan motor malfunction, defrost component malfunction, undercharged refrigerant, and wrong refrigerant. The third would be the high compression ratio. This refers to the ratio between your condensing and evaporating pressures. Since there is pressure-temperature relationship, the heat of compression will change depending on low and high pressures. If there is a high condensing and high evaporator pressure, the heat of compression will need to increase. The remedy for this would be first, improve internal and external ventilation. Check on your compressor's vents and ensure that they are not only clean but are sized appropriately to the demands of the machine. You should also ensure that the compressor room is sufficiently ventilated. If it's not, look into relocating your compressor into a space that is more suitable. Note that these checks should occur on a regular basis. Second is to inspect oil and lubrication levels. Lubrication acts as a coolant, so monitor the oil and lubricant levels in your compressor often. Additionally, if the oil is thin or appears watery, the heat level could already be too high. And then lastly, routine maintenance. The simplest action to take to prevent overheating is to have routine maintenance performed on your compressor. Frequent cycling. Compressors can also develop electrical problems. While not only cause of frequent cycling, a likely culprit is an electrical problem with your compressor. Cycling on and off is a red flag that there is something wrong with your HVAC system. It is possible that a frayed or worn wire is causing the problem. A remedy for this would be first check your air filter. A clogged air filter can cause a wide variety of air conditioning issues. It's a good idea to check your air filter and change it if it's cold with dust and temperature. Second is check your thermostat placement. Make sure thermostat isn't too close to the return air register so it doesn't get confused by the influx of cool air and produce the wrong readings. Next, check your air conditioner's refrigerant levels. It's good to check the levels so you could track down any leaks within air conditioning system. Then, replace low pressure control switch. If you are still dealing with short cycling issues, a replace of the component is an option. And lastly, check the compressor. Lastly is the motor won't start or hard starting. A failed compressor motor probably means a faulty start capacitor. The three main motors, namely compressor motor, blower motor, and outdoor fan motor, all use capacitors to function. The remedy for this would be, if the compressor won't start with air in tank, replace the check valve. If the compressor won't start with an empty air tank, replace the pressure switch if it isn't activating the pump motor. Replace the pump motor if it doesn't start when activated by pressure switch.
Push relay. Push relay, this server accepts push requests via HTTP and relays those requests to the appropriate push backends. Next is the overload protector. The overload protector sits near the condenser by the current start relay and ensures the condenser does not overheat while working. If the overload protector senses that the compressor is approaching failure from overheating, it will temporarily shut the compressor down to allow it to cool. Next is the thermostat. So the thermostat, it is the device to detect temperature changes for the purpose of maintaining the temperature of an enclosed area essentially constant. In a system, including relays, valves, switches, and etc., the thermostat generates signals, usually electrical, when the temperature exceeds or falls below the desired value. So the cabinet bulb, it is the embedded LED lamp in the cabinet open frame, is more energy saving, environmental friendly, and low in heat, and can provide sufficient light sources with less power consumption. And lastly is the switch. So it is a switch for summer and winter. Typically, summers are more humid, and what it does is turn on heaters in the doors or walls of the freezer or refrigerator to prevent condensation or ice buildup on the walls and doors. It's called a Mullion heater.
So we'll proceed to the last content of our topic, which is charging refrigerant in domestic refrigerator. Domestic refrigerators and freezers operates with very small refrigerant charges, and the charges must be administered accurately. This can be best achieved by using a visual charging cylinder, sometimes called a dial-A charge. We'll talk about charging refrigerant system. Charging refrigerant system is one of the most challenging and puzzling tasks a service technician will face. How much refrigerant a technician should put into a system when charging is a thought question to answer, because it is often system dependent. If there is no nameplate specifying the charge amount in ounces and pounds, there is really no straightforward answer, because all refrigeration systems differ in the amount of charge they hold. This is especially true for field assembled refrigeration system in which suction line length and size can vary considerably. So I will show you the visual charging cylinder. This is basically a small refrigerant cylinder with a liquid indicating sight glass or tube. In front of the sight glass and surrounding the cylinder and sight glass is rotating screen upon which are graduated scales for the common refrigerant R12, R22, and R502. Above the refrigerant scales is a temperature range. Fitted to the top of the cylinder assembly are a pressure gauge, a purging valve which is normally a Schrader type, and if a heater is incorporated, a pressure relief valve for the cylinder protection. At the base of the cylinder is a charging valve and hose connection. So let's go to the filling of the cylinder. Number 1. Obtain a service cylinder of the correct refrigerant. Connect it to the visual charger with a suitable hose. Number 2. Open the valve on the service cylinder and invert the cylinder. Number 3. Slacken the hose connection at the charging valve to purge air from the hose. Tighten the hose connection. Number 4. Open the charging valve to allow refrigerant liquid to flow by gravity into the cylinder. Observe the sight glass. When the liquid flow ceases, depress the purge valve and gently vent off a small amount of refrigerant vapor. When a pressure difference between the charging cylinder and the service cylinder is created, the liquid will begin to flow again. Repeat this operation until the required amount of refrigeration is in charging cylinder. Number 5. Close the valves on the both visual charger and the service cylinder. Number 6. The last, filling the cylinder. Disconnect the service cylinder. And we'll go to the charging the system. Number 1. Assuming a line tap valve has been installed and the system evacuated, connect the hose to the charging valve and the line tap valve. Open the charging valve and slacken off the hose connection to purge air from the hose. Close the valve. Number 3. Note the ambient temperature. Rotate the screen until the required refrigerant scale lines up with ambient temperature of the temperature scale. Number 4. Note the level of the refrigerant in the sight glass. Number 5. Open the line tap valve fully and slowly meter the prescribed amount of refrigerant into the system. If the visual charger has heated, this can be energized before opening the line tap valve to create a pressure difference between the charging cylinder and the system. 6. When the charge has been administered as indicated by the sight glass, close the charging valve. 7. Allow a few minutes for the liquid in the hose to vaporize and system pressure to equalize. Then close the line tap valve. And 8. Disconnect the visual charging and leak test the system. So that's the process of charging refrigerant in domestic refrigerator. And remember, an undercharge of refrigerant will result in long-running periods or continuous running. An overcharge of refrigerant will result in frosting back, overheating, increased running costs, and could possibly damage the compressor. Thank you.